Hello. Welcome back to the channel. So let's continue our discussion on infinite geometric series and let's calculate the sum of this infinite geometric series over here. So if we expand this geometric series, our series is basically 1 by 3 plus 1 by 3 square plus 1 by 3 cube, so on until infinity terms, right? So now we have to calculate the sum of this geometric series over here. And we have already derived the formula for an infinite geometric series sum in the last video. So if you have not watched my previous video on infinite geometric series sum, I'll highly suggest you to first watch my previous video in order to get the full idea about this video over here. So now you clearly notice that first of all, in order to evaluate the sum of an infinite geometric series, we have to notice what our common ratio is. And if the absolute value of a common ratio is less than 1, we use the formula which is a upon 1 minus r. So we know that our S infinity is a upon 1 minus r if our absolute value of r is less than 1, right? So in this case, let's first calculate r in this case. You know that in this formula, r is your common ratio and a is your first term in the series. So in this case, our a is 1 by 3 because you have to notice one thing, that your series is starting with n equals 1. You remember we derived the formula for an infinite geometric series in the last video, which was starting from n equals 0. So your formula was equal to this formula over here, where you took the a as your starting term. So the formula still remains the same, but in these type of questions, it's always better to expand your series first and then notice what your first term is and what your common ratio is, rather than relying on this sigma notation. So now we know that our a is 1 by 3. If we calculate our r, you know that we can calculate r very easily by taking any two terms. So let's take the first and the second term. If we have to calculate r, our r would be basically second term divided by first term. So 1 by 3 square upon 1 by 3. So our r is also equal to 1 by 3. And now since we have our r is 1 by 3. And in fact, the absolute value of 1 by 3 is 1 by 3. 1 by 3 is less than 1. So we can clearly use this formula over here. So in this case, our S infinity, the sum of our infinite geometric series, which is represented by this sigma notation over here, would be simply a upon 1 minus r. A is 1 by 3. 1 minus 1 by 3 because r is 1 by 3 as well. So it will be 1 by 3 divided by 2 by 3. So then it would be simply 1 by 2 in this case. So in this case, your sum of infinite geometric series, which is represented by 1 by 3 to the power n, starting from n equals 1 to n equals infinity, the sum is 1 by 2 in this case. The sum is half, and you can clearly notice that you have a finite value for the sum, which means that your series converge, right? So that was a simple problem to solve. We wanted to solve an initial problem which was simple so that we can build on the concepts that we covered in this video in order to solve the complex questions that we'll be dealing in the next video. So feel free to comment down on this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.